Hey, this is Jonas from ROOK. This is going to be a quick run through of our API reference and especially how the data JSONs are structured that include all the biomarker data. Um, while here in our talk documentation, you will see the tab of API reference. There's a few more administrative type of endpoints or like data examples around the user and the status for each of these users that are connected. But we will focus on those three pillars here, which is the actual biomarker data. So we have the data structured into three core pillars: physical, sleep, and body. And then within each of those, we will find summary and event data. In this first example here, we're looking at summary data. What is the difference between summary and event data? Summary data is at the end of a certain period of time. In this example, physical activity, it's at the end of the day. We have a summary that includes all the information of that day. So it is the max, the min, the averages, total time active, total time inactive, calories burned, total distance, distance covered, etc. That type of information, while event data would be information that we send throughout the day whenever something is happening and the data source is detecting an event, so something that has a start and stop date within the day. To first explain a bit more about the JSON structure, we will look at this physical summary structure. We see here on the right hand side the JSON example. A few things to point out here. So we have the client UUID. This is the client UUID that you would generate when you first create your account in our portal, in like our integration portal and administration portal. So this one is the client UUID we would use to then send back all of your information from your users to you. Then we have the user ID. The user ID you create for every user that is connecting a device. So that is the UUID we're going to use moving forward to connect all information to this user. And then the version 2 here, this one is something that's not too relevant for you because this is just that this is our second version of the API. So that's 2.0. The one that is important is this one here where we can see a document version 1. You will see that sometimes we get a document version 2 or 3, which is an updated version of, in this example, a physical summary for this user ID at this day we're looking at. So that's where the date time string comes into play. That is important because this means there is a more updated, more recent version for the same user for the same day. So it's always important to take the highest document version to have the most updated information for the user for that particular day and for that particular kind of data point or data points that we're looking at. So document version, yes, is an important one. Then we see here the data structure. So as I said, this is a physical summary. And that is obviously part of the physical health pillar, as we see here. What we see here in the metadata is the date time string. That is obviously important to know what date and timestamp is corresponding to that information for this user. And then we also see the source of the data. So we always find in the metadata where's the data coming from. And then what we can find is our structured data, which is all the information that we standardize, normalize, harmonize among all the different data sources. So we're talking about the non-proprietary data points such as heart rate, activity time, calories, distance, everything that can be standardized among data sources basically. And then we see obviously here some information such as active, inactive time, low intense time, etc. We see calories, we see distance, step count, elevation gain. If the user did some swimming, that type of information would go in here, walking, etc. So all types of activity data. Things such as floors climbed, heart rate information that corresponds through to the heart rate throughout the day, oxygenation, VO2, stress, etc. So there's different types of information in that JSON. And that is the standardized data. There's always also a non-structured data array that you can find within each of these JSONs, which is where proprietary data would be sent through. So if, for example, one device like a Garmin has body battery or these types of metrics that are proprietary to that data source, that would be sent through through the non-structured data points because there is no counterpart directly that can be harmonized, standardized, normalized from the other data source. So that goes into the non-structured data area. But it's not lost, so you still have access to that information. So that gives you a bit of an idea about the physical summary. Physical event data looks very, very similar. This is for an activity. So if I would go for a run, for a walk, this would generate an event data point that looks like this. And then here again, the JSON. So client UID, as we said, this is, okay, we know it's your data. We know which of your users we're talking to by the user ID that you create for us. Document, or like the version, as I said, is 2. That always has to be 2. Document version, as we said, has to be always the most updated, so that you have always the most recent data. And then in event data, we have something which is saying auto detect yes or no. That is for if the data was manually injected or if it was created and detected by the device itself. Activity event, and then here comes the activity data. So we're looking at, again, times been active, calories consumed during that activity, distance, and all the type of stuff like heart rate, movement. Depending on what activity, some information is obviously available, some is not available. That always depends on the information. For example, we would also have here position. That obviously only makes sense in activities where you actually change position. So some type of cardio sports that you would do outdoors, and then the stress as well, for example, during the event, etc. And then if we look at these other 2 events, we have heart rate events, which is like just as outstanding for just only the heart rate. That can be triggered from data sources from time to time. We then have oxygenation events, which is whenever we have some new information on the saturation in the blood, and that would be triggered by a data source, as well as stress events that can also be triggered throughout the day without that there's a total like activity happening, such as a walk or run. Then now in the second pillar, the sleep health pillar, what we're looking at here is the sleep data. As you can see, there's only sleep summary because we only get like a summary at the end of the night's sleep. So there's no events during the night sleep. But then again, client ID, user ID, version has to be 2. Document version, always make sure to have that updated. This is sleep summary data. And then we see here data such as how long was the sleep, the individual sleep stages, such as REM sleep, deep sleep, etc. We get scores on like efficiency, quality of sleep. We have heart rate information during the night, something like resting heart rate, which is often being used. And then HRV data, which is very valuable, especially the night HRV is obviously used for a lot of the data points, such as a readiness score or like, overall like readiness of the user for the next day, temperature, or the delta of temperature. So how much is it above or below baseline of the user, breathing and breathing rate, and then again, oxygen saturation or things like that can also be tracked often during the night sleep. Again, it depends obviously what data source we're looking at, what model and what data this model can extract, but that is kind of like how the summary of the sleep summary would look like. And then for body, I won't go into the details of each of those, but like we have again one body summary, which would be triggered at the end of the day. So at the end of the day, beginning of the new day, we would get the data for the previous day, following the same structure of client ID, user ID, version 2, document version. You need to keep updated for each of the user's data points, data structure, body summary, and then we would get here body metrics such as body composition data, blood glucose, blood pressure. Obviously, that's depending again on the data source and how often that is being updated. So it might not always be updated. That depends. Nutrition data would fall into the body pillar. Temperature can be falling into this one. It depends. If it's measured during the night and we're looking at delta, it would be in the sleep summary. If it's some other type of like body temperature measurement taken by a thermometer or so that's injected into Apple Health or so, then that's coming through the body pillar. Menstruation data would also sit in, for example, the body health pillar. That's the summary. And then we have almost all of these that we just saw in the summary also as events. So if someone steps on a smart scale, that might trigger an event and the data can be immediately sent over. So if you jump on a withing smart scale, you would get your body composition data, and then that body metrics data would be sent basically immediately after taking the measurement. Structure always the same, client ID, user ID, version 2, document version, repeated this a few times already, always has to be the most updated one for this user, for this date we're looking at, so that we have the most updated data in case the data source is providing us with some updated data. That happens from time to time after the first data was sent over. Heart rate from a body perspective, which is often like heart rate that might be measured throughout the day as a passive data point, so nothing during an activity or so. Oxygenation event can be triggered by the data source. Nutrition, so if someone logs nutrition and that's getting injected, for example, into again Apple Health or Health Connector, so we would extract that, and that would be part of a body event. Then some devices can track mood, where we're looking at hydration, blood glucose, so the continuous glucose monitor, such as the Dexcom, that type of information would come continuously through events for blood glucose, blood pressure, and then temperature from a body perspective, so body temperature taken by a thermometer. So again, so events would be triggered during the day, and it's great to use them as an interaction point to trigger some intervention, to use this to send a notification, update dashboards on a continuous basis throughout the day. But then the most accurate data is obviously always the summary data. So at the end of the day, we get the summary of everything that happened, in this case now, body-wise during that previous day. Or the same with like physical activity data, the summary is the most accurate because that's concluding the day. We have full data ready. We can calculate all the averages, mins, max. We can compare, and if someone has data, several data sources connected, we have already the combined data set and clean setups for the summary. So that's always the most accurate. So what makes often a lot of sense is to use event data during the day to show accumulated step count, calories so far during the day, or if there's some kind of blood pressure, body metrics being taken, to update those dashboards immediately to trigger some events. If someone has like high stress during the day or so, that's great for these types of actions. But then at the end, it always makes sense to overlay the data with what's the summary providing us at the end of the day. So that means, okay, at the end of the day, it still makes sense to take the total step count or total distance from the physical summary and override what we had so far in terms of like accumulated steps events, because that's then the final count and it's the cleanest version to kind of show the data in the end. In sleep, that's obviously a bit easier because we just get the sleep summary. I hope this is helpful. Just one more time, a few takeaways. Event data during the day. At the end of the day, it makes sense to update with summary data, those data points for each user. Always make sure to use the highest document version for that user ID for that particular day and data structure field. So it's the combination of user ID, document version, data structure, and datetime string. And then we're good to go. Thanks so much.